Now I'm going to describe an example problem where we have a so-called trigonometric equation, which is an equation involving trig functions that we'd like to solve. So the equation here is 3 sine of x minus 1 equals 0. The question is, well, what are the values of x that will satisfy this? So when you have an equation like this where you only have a single sine, cosine, or tangent, you can do it by just straightforward algebra to get it to an expression like a single trig function of x equals a constant. So let's do that first. So doing the algebra here, adding 1 to both sides and dividing by 3, we can reduce this to sine of x equals 1/3. So your first instinct should be to solve this by just saying x equals inverse sine of 1/3. And if I do that using my calculator here, let me just first check to make sure that I am in radian mode, and I am. If I do so, I can take the inverse sine of 1/3. This is not a special angle. This 1/3 is not the value of any of the sine, cosine, or sine function at any special angle. So the best we can do is to just get a decimal answer. So I get 0.3398. However, that is not going to be the only answer. This is in radians. That's not going to be the only answer, which I know by understanding that I can think of this equation as corresponding to all of the angles that correspond to the intersection of the unit circle with a horizontal line where y equals 1/3. So if that's y equals 1/3, I have this angle and I have this angle. So this angle is 0.3389 radians. How do we find this angle? We do it by the following. This angle here, the larger one, is going to be an angle that has this angle as its reference angle. So if you think about this quickly, this angle here is the same as this. So this larger angle here is exactly half the circle, which is pi, minus this. So this is going to be, what I'm going to get is one solution is inverse sine of 1/3, and the other solution is pi minus the inverse sine of 1/3. Now, if I want to be really careful, I also have infinitely many other angles that are coterminal to this. So the entire solution can be written in this way: 0.3398 plus 2 pi k, where k is any integer, or pi minus inverse sine 1/3 plus 2 pi k, where k is any integer. I can also write k in z. This is a symbol that just refers to all integers. So writing k element of z is the same thing as saying k is any integer. So these expressions here give us the entire set of solutions to this trigonometric equation. Okay, we should also understand how we could do something similar for either cosine or tangent. I will just go through what happens if we get something that reduces to cosine of x equals some constant. So if we had a problem that had some equation involving cosine, we could reduce it to this by the appropriate amount of algebra. As we've seen, this corresponds to the intersection of a vertical line with the unit circle. And the inverse cosine is always going to give us an angle in, pause it and tell me which quadrants? Quadrants 1 and 2. So that's going to be this angle here, and it is not going to give us this angle over here. So the solutions here are going to be inverse cosine of c is going to be the angle in quadrant 1 or 2. And if I want the other angle over here, you think about what this is going to be. There are two ways of saying it. One is instead of having a clockwise reflection, we have a counterclockwise reflection. So this is going to be just minus that. The other way of saying it is this angle here is the same as this angle here. And so if I think about going all the way around, it's going to be the entire circle minus that. And so the other solution is going to be 2 pi minus cosine inverse of c. So in general, the solutions, if I want to include all coterminal angles, are going to be these plus any multiple of 2 pi k. where k is any integer. So this is how you'd solve this for any particular value of c. Lastly, I should explain how we do this if we have tangent. And this is a little bit easier if you have an equation that's like tangent of x equals c. Remember, we saw that this is can be thought of as the angle of the intersection of the line y equals c times x, or a line of slope c. Sorry, let me write this with the unit circle. And the inverse tangent is always going to give us an angle in, pause it and tell me, in quadrants 1 or quadrant 4. But there's this other angle. How do we find it? Well, it's just the angle on the other side of the circle. So this is pretty easy to find. Whatever this angle is, this angle here is going to be that plus another pi radians. So in general, the solutions here are going to be x equals the inverse tangent of c, or inverse tangent of c plus pi. And then if we consider all coterminal angles, we can add any value of 2 pi times k, where k is an integer. So these expressions will give you all of the solutions to tangent of x is equal to a constant.